Now in the previous videos, we added our new machine and material to the iMachining database, as well as defined the important parameters that are required by the iMachining technology. We also created and defined the CAM part. The machine and material were selected when we added that first iMachining operation. And finally, we defined the machining of the outside contour. Now in this video, we're going to define an iRough operation to machine out the bulk of material from inside this pocket. We'll do everything that we would normally do, which includes completing the geometry, tool, and levels definitions. Then, when we reach the Technology Wizard page, I'll show you what it does and how it can be used more extensively. So let's get started by adding a new iMachining operation to perform the roughing of the pocket. Go to the SolidCAM Manager and right-click Operations, Add Milling Operation, and select 2D iMachining. The iMachining operation dialog box is displayed, and we'll use the default iRough technology since we want this operation to perform the roughing. On the Geometry page, click the New button to define the machining geometry. For this operation, the geometry is defined as a closed pocket with multiple islands. We should first select the outer pocket chain, followed by the 3 inner island chains. In the SOLIDWORKS graphics area, pick on the lower edge of the pocket contour. Close the chain using Auto Constant Z, and then accept the chain selection by clicking Yes when prompted. Now, let's make the 3 chain selections on the island contours. On the first island, we can close the chain by again using Auto Constant Z, and by then clicking Yes. Then go ahead and select the remaining 2 island chains. Since they're already closed, we can just click Yes to accept the chain selections. To complete and confirm the geometry definition, go ahead and click OK. Moving down the tree, let's define a new tool for this operation. After you switch to the tool page, click Select followed by the Add Milling Tool button. Define the tool parameters as follows. Enter a diameter value of 9.5 millimeters. Then, change the number of flutes to 4. Finally, go ahead and click the Select button to choose the tool for the operation. Now we have to switch to the Levels page to define the milling levels for the operation. Click the Upper Level button first, pick on the top face of the stock model, and then click OK to accept the selection. Next, click the Pocket Depth button. Pick on the lower face of the pocket to define the machining depth, and then click OK to accept the selection. Finally, let's now switch to the Technology Wizard page. So you may have been asking yourself, what exactly is the iMachining Technology Wizard, and what does it do? Well, in a nutshell, the Technology Wizard is an algorithm for producing on-the-fly cutting conditions for the current iMachining operation. This wizard takes many things into account when calculating the cutting conditions, including the tool data and milling levels that are defined for the operation. And like I've said before, even the machine and work material parameters affect the cutting conditions that are generated by the wizard. With the given values, the wizard provides perfectly synchronized sets of cutting conditions. Specifically, the Technology Wizard page lets us see those cutting conditions and their selections. And we can even make changes to the selections if we want. As you can see, this page is made up of 4 sections. They are Step Down, Machining Level, Output Cutting Data, and the Dynamic 3D Preview window. I want to talk to you about each of these sections, working my way from left to right and top to bottom. Now, the Step Down section consists of Input Options and the Output Grid. The Output Grid has 3 columns. They are Number of Steps, Step Down, and ACPs. Rows are created for each Step Down value that is not the same. The ACP value coincides with the color of the step-down row. In this example, the field is painted green, which means that this is a good situation for stability, and it's very unlikely that vibrations will develop. I'll talk more about ACPs later. The step-down by default is set to Automatic. Automatic will provide step-downs based on the defined tool information and the pocket depth. Automatic is one way the wizard calculates the depths. Now, because our pocket depth is 15 millimeters, Automatic generated one step at the full depth with an ACP value of an even 2.0. Let's click Save and Calculate to add the operation to the cam tree and calculate the iMachining toolpath. Then, click Simulate so we can look at the result based on these step-down values. When the simulation control panel opens, we'll continue to use the default HostCAD mode. Click the Play button. The simulation shows us that the tool is taking only one step down. After the simulation comes to an end, let's click Exit. This will take us back to the Technology Wizard page of the iMachining Operation dialog box where we left off. Now, if you would like, you can control the way the wizard calculates the depths. In order to do that, you would first need to switch the radio button to User Defined in the step-down section. A drop-down appears, enabling us to choose the method used for calculating step-down. In the list, we have two choices. We can manually enter either the number of steps or a specific step-down value. If we set the drop-down to number of steps, the total depth will be divided up by the number of steps. So let's enter 2 steps in the input field text box. Let's now calculate and simulate our results. First, click Save and Calculate to once again calculate the toolpath. Then, click Simulate to open up the simulation control panel. When we click Play this time, we'll see that the tool makes 2 step downs. After the simulation comes to an end, go ahead and click Exit. Now, click the drop-down and choose Step Down from the list. The value in the input field text box will be used for the depth of each step down until the total depth is achieved. If there is a remainder outside of the entered value, then the wizard will calculate and display the balance in the next row. Let's enter a step down of 3 millimeters. The results are 5 steps at a 3 millimeter depth, which will give us the 15 millimeter total depth. Let's calculate and simulate our results. Click Save and Calculate to calculate the toolpath. Once calculated, click Simulate. When the simulation control panel appears, go ahead and click Play to start the simulation. Based on our selections, the tool will now make 5 step downs at 3 millimeters each to achieve the full pocket depth. When the simulation comes to an end, click Exit. Now, when step down is chosen from the drop-down list, it is possible to enter a step down deeper than the cutting length of the tool. So, for example, let's switch back to the Levels page for just a moment. Manually enter a pocket depth of 30 millimeters, which is deeper than the cutting length of the tool at 24 millimeters. Now, move back to the Technology Wizard page. If we enter 30 in the input field text box for step down, the iMachining technology will calculate 1 step at the full pocket depth. However, if we choose number of steps for calculating step down, it is not possible for the wizard to generate depths that are greater than the cutting length of the tool. As you can see, there is 1 step that's equal to the cutting length of the tool and another step to remove the balance of material. If you want to use number of steps and would like the wizard to calculate 1 step at 30 millimeters, for example, the tool would have to be edited so that the cutting length is equal to or greater than the desired step down. Now, I want to talk to you about the machining level slider. This slider can be used to select from calculated sets of cutting conditions. The machining level slider gives you 8 levels to choose from. Each ascending level represents an increased material removal rate and higher aggressiveness. The level will be set according to the machine default level in the CAM part definition. The Output Cutting Data section offers 2 views, which show the final data from the Technology Wizard that will be sent to the iMachining toolpath. View 1 shows spindle speed, feed rate, step over max, and step over min. View 2 shows cutting speed, chip thickness, cutting angle max, and cutting angle min. When using the machining level slider to choose a set of cutting conditions, the output cutting data should be monitored. There are many factors in machining that can make one set of cutting conditions better than another. Some of these factors include fixture stability, cutting tool quality and stability, and/or risks associated with the forces from higher material removal rates. The machining level slider provides you with an adjustment for all these factors. The 3D preview window provides a 3D representation of the selected cutting conditions. The 3D view also shows the diameter, total length, and cutting length of the tool. Also shown is step down, step over, and aggressiveness. The tool is shown in two colors, yellow for the cutting length and gray for the remaining length of the tool. If there are multiple steps, the largest step down from the output grid will be shown since it's typically the most aggressive and should be monitored. Step over is represented by the red section in front of the tool. As the machining level slider is used, the 3D preview window updates. Levels 1 through 5 contain different step over values, and the remaining levels have a consistent step over. The aggressiveness is represented by the chips behind the tool. The 3D chips change color, quantity, and size to show that moving up in machining levels produces more, thicker chips with greater heat. The 3D preview window also shows how the chips should be evacuating the cutting area under good conditions as if we were actually machining this part. The chips should be shown discharging behind the tool. If the chips are shown sticking to the tool due to heat and are being brought back into the cutting area, then the potential for failure is quite high. Now I want to discuss what happens if you turn the wizard off. At the top right of the iMachining operation dialog box, you'll see there is a wizard on-off button. With this button, you can control whether or not the output cutting data gets written to the iMachining toolpath. When the wizard is on, which of course is recommended, the output cutting data values are being sent to the locations in the operation dialog box to be calculated along with the final toolpath. The spindle speed and feed rate are being sent to the Data tab of the tool page, as we can see here. The cutting angles are being sent to the Technology page. The depths are being sent here also. All of these fields are locked from being changed and are shown with a lock icon. Now if we turn the wizard off like so, the lock icons disappear and the fields are now open to be edited. Note that the wizard can still be used, but the output cutting data will not be written to the fields and no changes to the toolpath or G-code will be seen. Alright, so I'll end part 3 right here, but you can leave this iMachining operation opened. In the next part, we'll pick up where we left off and put everything back to have the wizard calculate the cutting conditions. So as you can see, the purpose of the machining level slider is to enable you to change all these values together in a synchronized manner, giving you easy and safe control over the aggressiveness. So now you know more about what the iMachining Technology Wizard does and how it can be used. In the next video, we'll put back the defaults and have the wizard automatically calculate the cutting conditions. And by doing so, we'll also complete the rough machining of the pocket, and I also want to point out specifically some of the areas where the roughing tool just can't physically fit. And this will segue into the need of an iRest operation prior to finishing. So stay tuned.